Now, hello class. In lesson 4.5, trigonometric functions of any angle, you're going to learn how to use the coordinate points and other trig information to find trig ratios or trig functions of any value, of any angle. So let's look at first what the definition again of the trig functions at any angle equals to. Now let's let theta be an angle that's drawn again in standard form, and P, which is a point with coordinates of x and y, be a point on the terminal side of this angle, as you see in the illustration right here. Okay. Now the distance from point P to the origin is referred to as r, this distance from this point here to that point r, and it can be found by using what looks like the Pythagorean theorem. But because the variables are x and y, we use x squared plus y squared equals r squared. And because this is supposed to represent a distance, this right here represents r, which is a distance, r always has to be positive. It has to be a positive number. So with this, the definitions of sine, cosine, and tangent and their reciprocals are the following. Sine is equal to the y coordinate divided by this value of r. Cosine equals to the x coordinate divided by this value of r. And tangent is the y coordinate divided by the x coordinate. And well, secant, cosecant, secant, and cotangent, since those are reciprocals of their respective function above, then cosecant is r over y, secant is r over x, and cotangent is x over y. Now, I can explain why this works, and I'll try to explain it. Why is it that we have this? Why does it equal to y over r and so on? Well, if you look at this triangle, and I draw a triangle right here, let's say theta is going to be this acute angle instead. Let's say this is theta on this acute angle here, okay? So this is my terminal side, and here is my point P, which is the coordinates x and y. So if I draw a vertical line downwards and from the origin draw a horizontal line, I have a 90-degree angle here. And this side here, again, that is the distance called r. So if I'm looking at this red triangle right here, the horizontal distance right here is the distance that we move again to get to this x coordinate. So let's say again, I'm at the coordinate of, for example, let's say I'm at the coordinate of 4, 3. Well, to get to 4, 3 from the origin, I would have to move 4 units to the right and 3 units up. So my horizontal distance is x, and my vertical distance would be whatever the y coordinate is. And because from right triangle trigonometry, we know that sine is the opposite over the hypotenuse, that gives us y over r. And then the same thing is true with cosine and tangent. Since cosine is the adjacent side, which is x over the hypotenuse r, we get x over r. And tangent, well, tangent is the opposite side divided by the adjacent side, so y divided by x. So if I look at this angle right here in the first quadrant, I can clearly see that the right triangle that I create using the coordinates of x and y are going to be, again, y over r, x over r, and y over x for sine, cosine, and tangent respectively. So that's how and why we end up again with this definition for 4 points on for an angle that is drawn in standard form. Okay, so as a result, that's why this is true. So let's use this information to find the 6 trig functions of an angle. So for this right here, again, let's draw a diagram of this. This is going to be in quadrant 4, because we would 9, 12 would be 9 units to the right, 12 units down. That would put the point P down here. So let's say that point P is on the terminal side of this angle theta. So to figure out what the 6 trig functions are, the sine of theta, cosine, and tangent of theta, and the reciprocals, well, we first have to figure out what the value of r is. We need to know what this distance is going to be. Well, to get that, we use our Pythagorean theorem. So x squared, which is 9 squared, plus 12 y squared, which is negative 12 squared, has to equal to r squared. So 81 plus 144 equals r squared. That adds up to 125. And then taking the square roots, which is 15, we get that the value of r is 15. So x equals 9, y equals negative 12, and r equals 15. And now we can find the 6 trig functions. We can start with sine. Sine gets the y coordinate and divides it by r. So negative 12 over 15. Since this is a common factor of 3, that's going to reduce to negative 4 over 5. Cosine of theta divides the x coordinate by r. So x is 9, r is 15, and since this has a common factor also of 3, that reduces to positive 3 over 5. And tangent of theta divides the y coordinates by the x coordinate. And again, we have a common factor of 3, and we end up with negative 4 over 3. Now the other 3 trig functions are simply the reciprocal of the first 3. So the reciprocal of sine is cosecant, so that's going to give us negative 5 over 4. The reciprocal cosine is secant, and that is 5 over 3. And finally, the reciprocal of tangent is cotangent. So that equals negative 3 over 5. Negative 3 over 4, I'm sorry. So there, those are your 6 trig functions and what they equal to. Now make sure again that when necessary that you reduce your ratio to the least common factor. So divide by the greatest common factor and write it again in simplest form. Let's do another example. All right, so for this example right here, again, this point is in quadrant 2, 5 units to the left and 2 units up. That would put our point P somewhere here. And if that's supposed to represent, again, a point on the terminal side of some angle, oops, what happened? Oh, here we go. Okay, let me move that. That is not drawn nicely, okay? So here we have point P. And we want to find again, and this is going to be our angle. So we want to find the 6 trig functions to this angle theta. So again, the first thing I need to do is figure out the value of r. I'm going to need, again, r first. So the distance of this red line, the length of that red line. So using our Pythagorean theorem, we're going to get our x value, square it, our y value, square it, and that's going to equal to r squared. So 25 plus 144, that's a total of 169, and the square root of that is 13. So we take the square root, and we end up with 13. So we know that x is negative 5, y is positive 12, and we just calculated that r is 13. So let's find the 6 trig functions. So starting off with sine, the sine of theta is y over r. The cosine of theta is x over r. The tangent of theta is y over x. So that's going to be a negative 12 over 5. And then the reciprocals. cotangent is negative 5 over 12. And there you have them, the 6 trig functions. Let's see, let's do one more example of this. So here's an example of a point that is in quadrant 3. So 2 units to the left, 1 unit down. Again, this is not drawn to scale, okay? But we have this angle theta here. So in order to figure out the 6 trig functions to this theta, I first need to figure out the distance of this red line, r. So negative 2 squared plus negative 1 squared equals r squared. So 4 plus 1 is 5. And taking the square roots, we end up with the square root of 5. So x is negative 2, y is negative 1, and r is the square root of 5. So the sine of theta is negative 1 over radical 5. But since this again is irrational, the denominator is irrational, we need to rationalize it. And to do that, remember the little trick I showed you, all you have to do is simply move this to the top and just get rid of the radicals, the square roots, the radical symbol, and keep the 5. So we end up with negative 1 radical 5, so negative 1 radical 5, which we can write it just as negative radical 5 over 5. So there, that's rationalized. Now the same thing with cosecant. Cosecant will divide the x value by r. So that's going to be negative 2 over radical 5, which when rationalized is negative 2 radical 5 over 5. And tangent is negative 1 over 2, which it reduces to a positive 1/2. And now we just flip those first 3 answers. So here, I'm not going to flip this one, the rationalized one. I'm going to simply flip because remember, those are equal. I'm going to flip the irrational one because that automatically puts the square root on top. So if I do this and flip this one, get the reciprocal of this, I'm going to have to rationalize it again and then reduce. So I'm just going to just flip this one. So flipping negative 1 over radical 5 puts this as negative radical 5 over 1, which is simply going to be negative radical 5. And the same thing with secant. Instead of getting the reciprocal of the rationalized one, I'm going to get the reciprocal of the one that's not rationalized. Because then that puts the radical 5 on top, the negative sign, of course, and then the 2 on the bottom. And that's already rationalized, so we're good. Had I flipped this one and got the reciprocal of this, I would have to rationalize it again and then continue reducing. So it's more work to get the reciprocal of the rationalized one. And then finally, the reciprocal of tangent. So that's 2. The reciprocal 1/2 is 2. And there you have your 6 trig functions. All right. Now let's discuss the signs of our trig functions. Well, on standard form, when we draw angles in standard form, again, just like with x and y values, our sine functions, again, change signs. Now in quadrant number 1, since x and y are both positive, that means that everything here is going to be positive because sine, remember, divides the value of y with r. And since r is always a positive number, dividing a positive number by a positive number is going to be positive. So sine is going to be, again, a positive number. Sine of theta is going to be positive. Well, the same thing with cosine. If cosine, which is x over r, are both positive, that means that for the cosine of any angle in the first quadrant, that's going to also give me a positive number. And since tangent divides y and x, and again, they're both positive, that means that the tangent of theta is going to end up equaling again to a positive number, which I'm going to write as saying that it's going to be a number greater than 0. Let me use that notation. Okay, it's going to end up giving me a positive number, which is obviously a number greater than 0. So in quadrant number 1, all 6, not just these 3, remember the reciprocals, all 6 of them are going to be positive. Now, in quadrant number 2, where our x is a negative value and y is a positive, the only trig function that is positive here is sine. Sine of theta, and of course its reciprocal, the cosecant of theta. Those are going to be positive, because in this one right here, remember, sine divides a positive y by r, which again is always positive. So that's going to give us a positive value. Cosecant just simply divides those numbers in the reciprocal order, so r divided by y. And again, those two positive numbers is going to be positive. Anything that uses x, like cosine and tangent, those are going to end up giving us a negative number. Cosine divides a negative x by a positive r, so that's going to be a negative number. And then, well, again, tangent divides a positive y with a negative x, giving us a negative number. So in quadrant number 2, the only thing that is going to be positive is sine, and of course, the reciprocal, cosecant. In quadrant number 3, since both x and y are going to be negative, then the only thing that's going to be positive here is tangent, because only tangent divides a negative with a negative. And of course, it's reciprocal. The reason that sine and cosine are not going to be positive here is because, remember, sine is y over r. But since y is negative, r is positive, that's going to give us a positive number anytime we divide a negative by a positive. And the same thing with cosine. Dividing a negative by a positive is going to give us a negative number. So that's why sine and cosine are negative. And of course, if those are negative, the reciprocals are also going to be negative as well. So only tangent is positive there. And in the last quadrant, where x is positive and y is a negative number, and r, again, the r that we create again from this point there to the origin, that number is always positive. The only thing that's going to be positive here is going to be cosine. And of course, the reciprocal of cosine, since that's the only thing that's going to divide a positive by a value, a positive r, or a positive r by a positive x. So in quadrant number 3, the cosine of theta is positive and the secant of theta is positive. A very easy way to memorize this of what's positive, at least for the first 3, all right, when it comes to sine, cosine, and tangent, is to remember the phrase, all students take calculus. All, meaning all of them in quadrant number 1. The second word starts with S, so that's going to be sine. The third word, referring to quadrant 3, starts with T, so tangent's positive. And the fourth word refers to the fourth quadrant, and that word starts with C, refers to cosine. So all students take calculus is a very good, easy phrase to remember in order to memorize which trig function is positive in the respective quadrant. Okay, so let's use now this information to figure out and find missing trig functions given one of them, given one trig function and the sine of another. So let's say here that we know that the sine of theta is 8 over 17. So let's start with that piece of information first, that the sine of theta equals to 8 over 17. Well, since sine is y over r, let's figure out what the x coordinate is by using our Pythagorean theorem. So if I substitute in 8 for y and 17 for r, we get this formula. So let's solve the equation for x. Now 17 squared is 289. We'll subtract the 64 from both sides and we get that x squared is 225. We'll take the square root and that is 15. Now, since we took the square roots, there's two possibilities for x. Remember, since we're talking about an x and y coordinate here, x can either equal to positive 15, or it can also possibly be that it equals to negative 15. So that means that the angle that we're going to create has two possibilities. We can be where x, our point P, is a positive 15 and the y coordinate being positive 8, or it could possibly be that our point P, that's on the terminal side of this angle that we want to create, is negative 15 and a positive 8. So there's two possible locations and two possible quadrants we can be in. We could either be in quadrant 1 or in quadrant 2, because those are the two possibilities that we can get a positive sign. Because remember, all students take calculus, so sine is positive here or in quadrant 2. So sine could equal to this number in two possible locations. And that's all because the x value can either be negative 15 and a positive 8, or a positive 15 and a positive 8. So we have two possible angles. We have this possible angle, or we have this possible angle. Okay? Well, let's see. Let's see how the second piece of information can help us. Well, since, let me just draw my terminal side. Let me put my terminal side in black. Okay, so those are the two locations my terminal side right here can be. Well, the next piece of information is knowing that tangent has to be a negative number. So that automatically deletes again quadrant 1, because in quadrant 1 everything is positive and we want our tangents to be negative. So the only way to get tangent to be negative is if our x value is negative as well. So that means that this is not going to be where our terminal side is, so our point can be here. And that means that our terminal side is going to be over here in quadrant number 2, and this is the angle that we're looking at. So knowing now that x has to be a negative 15, knowing from the beginning that y is 8, and again given from the very beginning that, let me make myself some more space, x is negative 15, y is 8, and r is 17, I can find the remaining 5 trig functions. Cosine of theta will be 8 over 17. The tangent of theta is 8 over negative 15, so negative 8 over 15. The cosecant of theta is 17 over 8. The secant of theta is 17 over, I'm sorry, I messed up on I messed up on cosine. Cosine should be negative 15 over 17. Which means that the secant is negative 17 over 15, and the cotangent of theta is negative 15 over 8. So there, those are your remaining 5 trig functions using again these two pieces of information. Let's see, let's do another example. So for this example right here, we're given that the tangent of theta is negative 35 over 12. So there's two possibilities here. Remember that tangent is the y value. Sorry, I'm not using a right triangle. We're using any angle, so not right triangles here. It's the y value over the x value, the x coordinate, y coordinate over the x coordinate. So here, there's two possible places that we can get a negative 35 over 12. We can get that x is equal to, that our point P could be negative 12 over 35, because this would be the y value, this would be the x value. So dividing a positive 35 by a negative 12, that gives me negative 35 over 12. Or it could possibly be that the point is a positive 12 and a negative 35. Because again, dividing a negative y by a positive x gives us again a negative 35 over 12. So these are the two possible points for where our angle is going to finish. So we can possibly finish in either in quadrant 2 or in quadrant 3. So P can either be here or it could be down here. Sorry, which quadrant? Not quadrant 3, quadrant 4. Down here. So that means that our terminal side could be here or it could be there. Okay? Well, in this situation, I would automatically go straight into the second one in order, before I decide which one it is, and use my Pythagorean theorem to figure it out. Let's figure out again which one of these two this is going to be at. Which of the two terminal sides is actually the correct one. Well, here we want cosine to be positive. And from our acronym that all students take calculus, cosine is only positive in quadrant number 1, which again, our terminal side's not going to be here. We don't have to worry about that. Or down here. Cosine is also positive down there. So that means that this is not going to be where the terminal side is. And instead, our angle theta is going to finish at this side here. So to find the remaining 5 trig functions, I first need to figure out what the value of r is. So now knowing that our angle again has the angle ends, or the terminal side of our angle is in quadrant number 4, that means that the point we're going to use is this point right here. So we're not using this point, and instead of using that. So x is going to be 12, y is going to be negative 35, and all I'm missing is figuring out the value of r. So using our Pythagorean theorem of 12 squared plus negative 35 squared equals r squared, we get 144 plus 1225 equals r squared. And when I add those numbers together, that's going to give me a total of 1369. Now the square root of this 1369, that equals a total 37. So our r is 37. So now with all of those values there, I can find the remaining 5 trig functions. So starting off with the sine of theta, we'll get the y value of negative 35 over a positive 37. That will be negative 35 over 37. There's no common factor there, so we don't have to simplify. The cosine of theta, that's a positive 12 over a positive 37. Then we have the tangent. Well, we don't need the tangent because that one's already provided for us. We need to find the remaining ones. So we'll go to the reciprocal ones. Starting off with the cosecant of theta. That's the reciprocal of sine. So that's a negative 37 over 35. The secant of theta is the reciprocal of cosine. So that's 37 over 12. And then the cotangent, which is negative 12 over 35. And there you have the remaining 5 trig functions. Let's see, let's do one last example. So on this example here, very similar to the first example we did, we have that the cosine of theta is negative 5 over 12. So since cosine, I'm going to write negative 5 over 12 like this. Since cosine divides the x value by the r value, in this situation here, because of this negative sign, and I kind of prematurely put it on the top, because I knew that the x value has to be negative. Remember, the r is the distance from the center of the coordinate, again from the origin 0, 0, to this point P that's on the terminal end of our angle theta. So r has to be positive. And the only way to get a negative 5 over 13, to get that negative fraction, is if the 5 has to be negative. So here we know that x equals to a negative 5 and r is going to be 13. So to figure out the value of y, in order to see where we're going to be, where the possible quadrants we're going to be in, we're going to use our quadratic formula of x squared plus y squared equals 13 r squared, which again is 13. So like I said, we know that r is negative 5. We don't know what the y value is, and r is 13. So this is 25, 169, and that's going to give us a total of 144. Taking the square root of that number, we get that the value of y is positive or negative 12. So a possible 12 or negative 12. So with x being negative 5, that puts our point P on either negative 5, 12, or that puts point P at negative 5, negative 12. So there's two possible points, two possible quadrants we can be in that our angle could, the terminal side of our angle could be in. So let me first look at this place here. Oh, sorry, wrong place. Negative 12, positive. So that would be here in this quadrant, quadrant number 2. And the other point could be down here, and negative 5, negative 12. Okay. Now, using the other piece of information that we have, that sign has to be a negative number. Well, we know that it can't be obviously in quadrant 1, because we don't care about what's happening in quadrant 1 and quadrant 2. We're interested in what's happening in quadrant 4. I'm sorry. We're interested in what's going to happen in what's happening in quadrants 2 and in quadrant 3. So from our acronym that all students take calculus, we know in quadrants 2, sine has to be a positive number. But we don't want sine to be a positive number. We want sine to be less than 0. So we need our sine to be a negative number. So the only way that's going to happen is if our terminal side goes through this point down here, where y is a negative 12 and not a positive 12. So this cannot be the point that our terminal side is going to go through. Our terminal side has to go through the point in quadrant 3. So our angle theta is going to look like this. And now I can figure out the remaining 5 trig functions. So x has to be a negative 5, y is a negative 12, and r is going to be the 13. Again, this distance r is 13 units. So let's figure out the remaining trig functions. So starting off with sine of theta would be negative 12 over 13. So that's negative 12 over 13. Cosine, well, we don't need to do cosine because that one's given to us. Again, that's that one right there. We were only looking for the remaining trig functions. So tangent is negative 12 over negative 5. So that's a positive 12 over 5. And then we can move on to the reciprocal one. So the reciprocal of sine is negative 13 over 12. The reciprocal of cosine is negative 13 over 5. And the reciprocal of tangent is positive 5 over 12. And there you have it. The remaining 5 trig functions. There you are. There you go. And well, that concludes our examples on finding the trig functions of any angle. Now, if you have any questions, please send me a message on Remind or through email. And like always, I appreciate you watching, and I hope you have a great day. Goodbye.